In today's session, we'll learn about trigonometric ratios. Before we start, let's understand what is trigonometry. Trigonometry is a branch of mathematics which deals with angles, measurement of angles, and the problems allied with angles. So, we mostly deal with the right angle triangles in trigonometry. Let's have a close look on the sides and angles of a right angle triangle. We have three sides in any triangle, and in a right angle triangle the longest side is known as hypotenuse and the other two sides are known as perpendicular and base. See, the term perpendicular and base will change depending upon the angle that we are dealing with, as trigonometry deals with angles, as I said before. So the angle which we are dealing with will decide whether these two sides are, which of these two sides is a perpendicular and which of these two sides is the base. So for that, let's understand in detail. As in given figure triangle ABC, we know the longest side is hypotenuse, but what if we have to decide which side is perpendicular or base, then side AB can also be it can be perpendicular as well as base, and side BC can also be perpendicular as well as base depending upon the angle that we are dealing with. Like in first case, if we take angle C as the angle that we are dealing with, then the side adjacent to angle C, if we take angle C as theta, then the side adjacent to angle C, that is theta, will be the base, and side opposite to angle theta will be perpendicular. Similarly, if we take angle A as the angle of measurement, then the side adjacent to angle A will be base and the side opposite to angle theta will be, that is angle A, will be the perpendicular. If you find your perpendicular and base correctly, then finding trigonometric ratios will not be a difficult task. So one thing that you have to keep in mind while finding your base and perpendicular is that the angle that we are dealing with. So the side which is opposite to the angle that we are dealing with, that side is the perpendicular, and the side which is adjacent to the angle that we are dealing with will be called as the base of the triangle. So once you have hypotenuse, perpendicular and base correctly, you can find out the trigonometric ratios. As it is a right angled triangle, one angle is 90 degree, and what is the sum of other two angles? The other two angles are acute angles and their sum is also 90 degrees, as sum of all the angles in a triangle is 180 degree. Now let's understand trigonometric ratios. To start with, let's once again understand how do we decide which side is perpendicular and which side is a base. For this, we'll take two triangles, right angled triangles. One is triangle ABC, right angled at B, and another is triangle PQR, right angled at angle Q. In triangle ABC, if we take angle C as theta, then the side opposite to theta, that is AB, will be our perpendicular, and the side adjacent to theta, that is side BC, will be our base. But in triangle PQR, angle P is our angle theta, so side PQ which is adjacent to theta is base, and side opposite to theta is QR, which is our perpendicular. So our first step is to find out for angle theta what is our base and perpendicular. Hypotenuse obviously will be the longest side of the right angle triangle. Now let's move on to trigonometric ratios. What are trigonometric ratios? The ratios of any two sides of the triangle are called as trigonometric ratios, and different names are given to different combinations of ratios. For example, sine theta, cosine theta, tangent theta, cosecant theta, secant theta, and cotangent theta. And in short, they are known as sine theta, cos theta, tan theta, cosec theta, sec theta, and cot theta. So you have to quickly learn these names: sine, cos, tan, cosec, sec, cot in sequence. Before I talk about their ratios, let's understand what is their reciprocal relations. So all these trigonometric ratios have reciprocal relations. For example, sine theta is reciprocal of cosec theta, and similarly cosec theta is reciprocal of sine theta, and cos theta is reciprocal of sec theta, and similarly sec theta is reciprocal of cos theta, and lastly tan theta is reciprocal of cot theta, as well as cot theta is reciprocal of tan theta. Also, tan theta is sin theta upon cos theta, and cot theta is just opposite of tan theta, that is cos theta upon sin theta. And if we multiply tan theta and cot theta, we get 1. Now let's learn a very important mantra that's going to help us in entire trigonometry. It is Pandit Badri Prasad Har Har Bol. So this PBPHHP stands for perpendicular, base and hypotenuse. So in sequence you write down sine, cos, tan, cosec, sec, cot and write down PBPHHP, that is Pandit Badri Prasad Har Har Bol. Now if you see the blue color arrows, sine theta is the ratio of perpendicular and hypotenuse. You don't have to remember, just remember the mantra and then you will be able to find out the ratios of sine theta. Similarly for cos theta it is base upon hypotenuse, b upon h, and for tan theta it is p upon b. From this mantra you can find out also if you divide sine theta and cos theta, p upon b upon h, you will get p upon b. Similarly for cosec theta, now see the green arrows, it is now reciprocal of sine theta, so it is h upon p. Sec theta is reciprocal of cos theta, so it is h upon b, and cot theta is reciprocal of tan theta, so it is base upon perpendicular. Just by remembering these ratios, you will be able to solve many of the problems related to ratios. Let's get started with two sums. So the first problem is, if sine theta is equals to root 3 upon 2, then find the value of all the trigonometric ratios. That means value of sine theta is given and we have to find the values of cos theta, tan theta, cosec theta, sec theta and cot theta. For this we will make a right angled triangle first. So we have drawn a triangle ABC, right angled at B, and let's assume that angle C is the angle theta given to us. So BC will be our base and AB will be our perpendicular. Now remember the mantra PBPHHP, that is Pandit Badri Prasad Har Har Bol. Now from here find out what is sine theta. Sine theta is P upon H, which is given. So given is sine theta is equals to root 3 upon 2. This is given. And what is sine theta? Sine theta is P upon H. So root 3 upon 2 is equals to P upon H. So from here we can say that the value of P is root 3 and value of H is 2. So now if we apply Pythagoras theorem on triangle ABC, we can find the value of B, because Pythagoras theorem says hypotenuse square is equals to the sums of squares of perpendicular and base. So if we put the values of H and P, we can find out the value of B. Here in this case, when we solve, we get that the value of B is 1. Now we have the values of perpendicular, base and hypotenuse. We can use these values to find the trigonometric ratios. So sine theta, which is already given, is perpendicular upon hypotenuse. That means perpendicular is root 3 upon hypotenuse is 2. So value of sine theta is root 3 upon 2. Similarly, cos theta is equals to b upon h, and our value of b is 1 and h is 2, so value of cos theta is 1 upon 2. Same goes for tan theta, which is equals to p upon b. P is root 3 and b is 1, so root 3 upon 1 is root 3 itself, so value of tan theta is root 3. Now cosec theta is just reciprocal of sin theta, so it is hypotenuse upon perpendicular. Hypotenuse is 2 and perpendicular is root 3, so value of cosec theta becomes 2 by root 3. Next is sec theta, which is h upon b, hypotenuse upon base, and value of hypotenuse is 2 and base is 1, so value of sec theta is 2. Similarly, cot theta is reciprocal of tan theta, b by p, so its value is 1 upon root 3. Let's take another example. If 3 tan a is equals to 4, then prove that square root of sec a minus cosec a upon sec a plus cosec a is equals to 1 upon root 7. So for this, we'll start with drawing a right angle triangle ABC, right angle at B, angle theta at C. So our perpendicular is AB and base is BC. AC being the longest side is our hypotenuse. First of all, please read this angle theta as angle A, because in the question we are given the value of tan A. A is our angle. So I have drawn theta here at angle C. So please read this angle C as angle A and convert that angle A as angle C first. And then let's move on. We are given that 3 tan A is equals to 4. From here we get that tan A is equals to 4 by 3. Now, if we write our mantra in rough work, Pandit Badri Prasad, Har Bol, PBP, HHP, then we know that value of tan A is P upon B. So, we can say that P is 4x and B is 3x. So, if we apply Pythagoras theorem to triangle ABC, we can find out the value of H. So why have we taken x here? The reason for that is we are dealing with ratios. We are not sure about the value. The value of p and b can be something else. It could be, a multiple of x. So the ratio is 4:3. So that is the reason we have taken the values in x. So here, after applying Pythagoras theorem, we get the value of h as 5x. This 3x is wrong. I'll correct it soon. So the value of h that we get is 5x. So we have perpendicular as 4x and the base as 3x, also hypotenuse as 5x. Let me erase this wrong value of h first. This should not be 3x, this should be 5x. So let's correct it first. So now, using the values of perpendicular base and hypotenuse, we find out the value of sec A. We need the values of sec A and cosec A only. So sec A is hypotenuse upon base, which is 5x by 3x, that is 5 upon 3, and cosec A will be h upon p, that is 5x upon 4x. So cosec A will be 5 upon 4. Now we'll place these values of sec A and cosec A in the left hand side of the question, and we get first we note down the values of sec A and cosec A. Sec A is 5 by 3 and cosec A is 5 by 4, and the LHS in the question is sec A minus cosec A upon sec A plus cosec A. So we place the values of sec and cosec A in this left hand side, and we get 5 by 3 minus 5 by 4 upon 5 by 3 plus 5 by 4. Now we just have to subtract and add the numerators and denominators. So for that we'll take the LCM of 3 and 4, which is 12, and we get 20 minus 15 by 12 upon 20 plus 15 by 12. So 12 gets cancelled with 12 and we get 5 upon 35 in the square root. And next 5 gets cancelled with 35 and we get square root of 1 by 7, which can be written as 1 upon root 7. That is our RHS. Hence we can say that we have proved what was asked.